So due to the way that they can be seen in terms of x and y values, we can see nice patterns for the behavior of trig functions in terms of the quadrants of the rectangular plane. That is, if we look at the quadrants like so, we can see that in the first quadrant, all of our trigonometric functions are positive. In the second, sine and cosecant are positive. In the third, tangent and cotangent are positive because there we have x and y both negative, so it's a double negative. While in the fourth, x is positive but y is negative, so only cosine and secant will be positive. And when it comes to this, probably what you're most used to remembering is the mnemonic in terms of sine, cosine, and tangent. A for all, S for sine, T for tangent, and C for cosine, with whatever attached you have to that. A, students take care. A, strider tracks carefully. Average snowmobiles take carrots. Whatever works for you, as long as you have something that can bear in mind that pattern. The one that's most commonly seen for this class is all students take calculus. It's good information to have and can help you solve problems like our next example. So for this example, we suppose cosine of theta is equal to negative 3/5 and cotangent is positive, where we want to find tangent and sine of that same angle theta as a result. So from what we have here, we can make some interpretations. First, we can notice that because we have cosine is equal to negative 3/5, and cosine is always given as x over r, x has to be negative 3, and r has to be 5. Because our radius, by construction, is never going to be negative, x has to be the negative one. And because we have that cosine and cosine is negative, and cotangent is positive, that means we have to land in that third quadrant where where tangent and cotangent are the only positive functions. But anyway, from here we have x is 3, r is 5, so if we wanted to get x, we use the relationship x squared plus y squared equals r squared, that is the Pythagorean theorem. Where here we would have x is equal to r squared, 25, minus y squared, which should be negative 3 squared, 9 minus 9, which gives root 16. And in this case, by construction, that's going to end up being negative 4 because we're working in the third quadrant where y values would end up being negative. And I don't know why I said that should be x, because that shouldn't be x. We already have x. We wanted y, didn't we? Anyway, we now have y, x, and r, so we can find our trig functions. In particular, we just want sine of theta and tangent of theta, but to be clear, it wouldn't be that much more work to get the other, what would it be at this point, 3 from what we have? But we're only looking for 2 right now. In any case, our value for sine would, as always, be y over r. So here, that would be negative 4 over 5, or negative 4/5. Meanwhile, tangent, as always, is y over x, which here would be negative 4 over negative 3, or 4/3. And we're going to finish this section on a quick word from reference angles before moving on to 4.5.